A superspreading event is an event in which an infectious disease is spread much more than usual, while an unusually contagious organism infected with a disease is known as a superspreader. In the context of a human-borne illness, a superspreader is an individual who is more likely to infect others compared with a typical infected person. Such superspreaders are of particular concern in epidemiology. Some cases of superspreading conform to the 80-20th rule, where approximately 20% of infected individuals are responsible for 80% of transmissions. Although superspreading can still be said to occur when superspreaders account for a higher or lower percentage of transmissions. In epidemics with such superspreader events, the majority of individuals infect relatively few secondary contacts. SSEVs are shaped by multiple factors including a decline in herd immunity, nosocomial infections, virulence, viral load, misdiagnosis, airflow dynamics, immune suppression, and co-infection with another pathogen. Although loose definitions of superspreader events exist, some effort has been made at defining what qualifies as a superspreader event. Lloyd Smith et al. Define a protocol to identify a superspreader event as follows. This protocol defines a 99th percentile SSEV as a case which causes more infections than would occur in 99% of infectious histories in a homogeneous population. During the SARS-CoV-1 2002 to 2004 SARS outbreak from China, epidemiologists defined a superspreader as an individual with at least 8 transmissions of the disease. Superspreaders may or may not show any symptoms of the disease. SSEVs can further be classified into societal and isolated events. On April 2020, Jonathan K. reported in relation to the COVID-19 pandemic. Putting aside hospitals, private residences and old age homes, almost all of these superspreader events face-to-face professional networking events and meetings. Meat processing facilities, funerals. Superspreaders have been identified who excrete a higher than normal number of pathogens during the time they are infectious. This causes their contacts to be exposed to higher viral, bacterial loads than would be seen in the contacts of non-superspreaders with the same duration of exposure. The basic reproduction number R0 is the average number of secondary infections caused by a typical infective person in a totally susceptible population. The basic reproductive number is found by multiplying the average number of contacts by the average probability that a susceptible individual will become infected, which is called the shedding potential. R0 equals number of contacts times shedding potential. The individual reproductive number represents the number of secondary infections caused by a specific individual during the time that individual is infectious. Some individuals have significantly higher than average individual reproductive numbers and are known as superspreaders. Through contact tracing, epidemiologists have identified superspreaders in measles, tuberculosis, rubella, monkeypox, smallpox, Ebola, hemorrhagic fever and SARS. Studies have shown that men with HIV who are co-infected with at least one other sexually transmitted disease, such as gonorrhea, hepatitis C, and herpes simplex 2 virus, have a higher HIV shedding rate than men without co-infection. This shedding rate was calculated in men with similar HIV viral loads. Once treatment for the co-infection has been completed, the HIV shedding rate returns to levels comparable to men without co-infection. Herd immunity, or herd effect, refers to the indirect protection that immunized community members provide to non-immunized members in preventing the spread of contagious disease. The greater the number of immunized individuals, the less likely an outbreak can occur because there are fewer susceptible contacts. In epidemiology, herd immunity is known as a dependent happening because it influences transmission over time. As a pathogen that confers immunity to the survivors moves through a susceptible population, the number of susceptible contacts declines. Even if susceptible individuals remain, their contacts are likely to be immunized, preventing any further spread of the infection. The proportion of immune individuals in a population above which a disease may no longer persist is the herd immunity threshold. Its value varies with the virulence of the disease, the efficacy of the vaccine, and the contact parameter for the population. That is not to say that an outbreak can't occur, but it will be limited. The South Korean spread of confirmed cases of SARS-CoV-2 infection jumped suddenly starting on the 19th to the 20th of February 2020. On the 19th of February, the number of confirmed cases increased by 20. On the 20th of February, 58 or 70 new cases were confirmed, giving a total of 104 confirmed cases, according to the Centers for Disease Control and Prevention Korea. According to Reuters, KCDC attributed the sudden jump to 70 cases linked to patient 31, who had P.